Hello everyone, welcome to IM Express. This is our new question. It's a geometry question. As usual, pause the video, take 3 minutes to solve the question and then come back for solution, right? So this is a semicircle. It's again a semicircle and it's a semicircle also. There are three semicircles, right? And one more thing is given, DC and AE are parallel. So the theorem which we are going to use here is what? If there is a right angle triangle, if there is a right angle triangle, like here it is given DAB, it's what? DAB, this point is B. I think it's not clearly visible, right? So in the right angle triangle DAB, we have drawn a perpendicular from the point A, AC, and the theorem is AC square, the perpendicular square, is equivalent to BC and CD multiplied, BC product CD, right? This is the theorem. uh, how can I prove this? If you need the proof, you can see here ABD is a right angle triangle and right angle at A, and AC is perpendicular to BD. So here in this triangle I can say triangle BCA. Triangle BCA is similar to triangle ACD. Why similar? Because one angle is right, one angle is common, then definitely it should be similar. Third should also be equal. In similarity, ratio of corresponding sides are same, and using this thing we can prove that AC square is BC times DC. This is the theorem. In one more way we can use the same theorem. What is that? If there is a semicircle, if there is a semicircle and if I draw a perpendicular from any point on the base, if I draw perpendicular, perpendicular means it's a right angle triangle. If I draw perpendicular from any point of the circle on the base, then it will divide the base in two parts. Let's say this is part A, length of this part is A, and length of this part is what? B. Divide the circle into two parts. And the perpendicular is, I can assume P. Perpendicular I am assuming P. So what is the theorem here? Theorem says P square means perpendicular square is equal to the product of two parts of the base, is A times B. This is the theorem. How the theorem comes? The theorem is same as this one, because if I try to join the point from here and here, it will be a right angle triangle, because already we know that angle in a semicircle is always the right angle triangle. This must be right angle triangle. It is perpendicular from right angle triangle. The theorem is exactly same as this. So this is a very useful theorem. It is used many times. You should remember this. And we'll solve the question using this theorem, right? So starting solving our question which is given to us, this is our question. AB is given to us 4. Okay, let's say this is the center of AB and this is the center. So this line must be 2. This length must be 2. Radius is 2 because diameter is given to us 4. CD is 6, diameter is given 6, so I can say radius is 3. Right? I hope it's clear. And the most important point is all the radii in a circle are same. All the radii is same. So if it is 3, then if I draw the radius, this one, the perpendicular one, this also must be 3. This is also a radius and this is also 3. I hope it's clear. Then further I can say if I drop a perpendicular from C, that also should be 3. Right? I hope I am clear. This also must be 3. One more noticeable point is here. Whenever there are tangent circles, question is solved maximum times when we join their centers. And for sure, if I join the centers of two tangent circles, it will always go through the point of contact. It will always pass through the point of contact, right? If I join this red line, I can say this radius is 2 given to us and this radius is 3 given to us. Okay, if I assume the centers as O and O dash, if I assume the centers are O and O dash, then I can make a triangle here that is O, it is O dash, and the perpendicular, this point I can assume P, the perpendicular P. So we can use Pythagoras theorem here. This side is given to us 3 plus 2, which is 5. This perpendicular is given to us 3. So 5, 4, 3. We know the triplet 3, 4, 5. The base must be 4 using the Pythagoras theorem. 5 square minus 3 square and the square root, base is 4. So from here to here, the length we have got 4. And this already we know it is what? 2. This is given to us 2. And can I say this one is 3? Why this one is 3? Because these are two perpendicular. So the top 3 should be the bottom 3. It's a rectangle. So this must be 3 because OC is 3. Now the time has come when we'll use the theorem which we have learned. This is point E from our figure. This is point A from our figure. And this is point C from our figure. I hope you know. This is point A from our figure. This is point E from the figure. This is point C from the figure. And what I can conclude in our figure, this from here to here, it is what? It is 2 plus 4, 6, 6 plus 3, 9. This part is 9. What is the value of this part? We don't know, that we need to find out. Assume karte hain x. We assume it x. And what is the perpendicular? Perpendicular is 3. Perpendicular is 3. So we are using the same theorem which we have learned. And what is the theorem? The perpendicular square means 3 square must be equivalent to the two parts, multiplication of two parts, 9 times x. So what is x? It is 9 by 9, which is 1. The value of x is 1. And we have got the base AE. Question is, what is the length of AE? What is AE here? From the figure, it's 2 plus 4 plus 3 plus 1. It is finally 10. The base is 10 centimeter. Answer option D. D is the right answer. I hope it's clear. Thank you.